Hello everyone! Today's video will introduce a new product, WaveSentry. WaveSentry is developed based on ESP32 Marauder. WaveSentry is divided into two versions, WaveSentry and WaveSentry Pro. WaveSentry is the basic version, which includes functions such as audio receiver, Wi-Fi and Bluetooth analysis. WaveSentry Pro is the professional version, which includes audio receiver, Wi-Fi and Bluetooth analysis, as well as thermal imaging functions. It should be noted that the firmware used by WaveSentry Pro is customized. If you flash the ESP32 Marauder firmware yourself, the radio and thermal imaging functions will not be available, and the device cannot work because WaveSentry has a different definition of chip pins compared to ESP32 Marauder. The firmware of WaveSentry is open source. However, currently the thermal imaging function firmware is not open source. Today, we will introduce how to use the WaveSentry Pro. By observing the device, we can know that this button is used to control the power on or off of the equipment. Pressing upwards is for turning on the device, and pressing downwards is for turning it off. The reset button helps the device complete the restart function. Flash is related to firmware burning. This device is also equipped with a 360-degree knob for easy selection. At the bottom of the device, there is a headphone interface and a Type-C USB port. On the back side of the device, you can see two speaker sound hole designs and a thermal imaging camera. This is our trademark logo and the logo of open source SDAR Lab. When opening the device, we can see that it has four main functions: Wi-Fi, Bluetooth, thermal image, and radio receiver. I will introduce them to you step by step. Here we go. Probe Request Sniff. The Probe Request Sniffing function is a passive wireless intelligence collection tool. It listens to the probe requests sent by Wi-Fi devices, captures the randomized MAC addresses of the devices, and displays them on the screen. Each line of data represents a captured probe request. The data consists of the MAC address of the Wi-Fi probe signal transmitter and the network name that the device is searching for. Beacon Sniff. The beacon sniffing function is a wireless network discovery tool. It listens to the beacon frames broadcasted by the APs regularly, providing a detailed list of surrounding networks. Each line of data in the list represents a discovered wireless network and displays key information, including signal strength, channel, and network name. Packet Monitor. The packet monitoring function provides a real-time, bottom-level view of the wireless world. Unlike other sniffers, it does not provide organized information, but displays the captured data packets directly through a chart format for you. Scan Apps. The Scan APs function actively scans all wireless networks that are broadcasting in the surrounding environment. Each row of the list represents a discovered wireless network and displays key information, including signal strength, channel, and network name. Raw Capture. The Raw Capture function will find all wireless network data in the surrounding environment and display the corresponding MAC addresses and ASI. ASI is the received signal strength indicator, indicating the strength of the signal. Station Sniff. In this function, any device connected to the network you select will be detected. This function is mainly used for device tracking, physical positioning, and selecting targets for subsequent attacks. Signal Monitor. Using this function, you must connect to the network. It will tell you the difference in signal strength of the network. Bluetooth sniffer. This function enables the Bluetooth controller of the ESP32 to enter the listening mode, capturing the Bluetooth broadcast packets and broadcast scan responses transmitted in the air. It does not connect to any device and is completely passive, thus not being detected. The relevant Bluetooth information will be displayed on the screen, including the Bluetooth MAC address of the transmitting device and the received signal strength indicator ASI. Flipper sniff. The sole objective of Flipper sniff is to detect nearby Flipper 0 devices that are in an active state. When Flipper 0 devices start certain radio frequency functions, their Bluetooth modules will periodically send out specific broadcast packets. Flipper sniff is specifically designed to monitor these broadcast packets. AirTag sniff specifically listens for and captures the Bluetooth broadcast signals sent by Apple AirTags or compatible Find My accessories, detecting whether there are any unknown AirTag devices around that might be used to track you. Apple's AirTags and compatible Find My devices regularly broadcast an encrypted data packet via Bluetooth, which is relayed by nearby Apple devices and reported to iCloud. This function specifically listens for this specific format of broadcast packets. Thermal image. The thermal image function utilizes the thermal imaging sensor on the device to convert the infrared radiation emitted by object surfaces into visible images. Different colors represent different temperatures, transforming the intangible thermal energy into visual data. Next, I will demonstrate the application of the thermal imaging function through several practical scenarios. First, I will aim the device at my finger. As you can see, the thermal imaging effect of the finger is immediately displayed on the screen. The areas with higher temperature are shown as bright yellow or orange, while the areas with lower temperature are shown as blue or purple. This intuitively shows how thermal imaging can real-time reflect the temperature distribution of objects. Then I will aim the device at a camera in the room. In the thermal imaging picture, the camera, which is working, emits higher heat than the surrounding environment, so a clearly hot area is shown on the screen. This function is particularly practical when you stay in a hotel. You can use it to detect if there are hidden cameras for filming in the room. For users who often stay in hotels for business trips, this function is really very useful. I hope these demonstrations can help you have a deeper understanding of the practicality and wide range of applications of the thermal imaging function. Radio receiver. The radio receiver is an AM or FM radio. You can set the channel you want to listen to and tune into it while also adjusting the appropriate volume. Let me demonstrate for you how to operate. First, to select or adjust the frequency, please gently touch the frequency display area with your finger, then turn the knob for precise adjustment. The interface will respond to your operation in real time. The same applies to the switching of the receiving modem or FM. Simply touch the mode switching area and then rotate the knob to complete the selection. After setting the desired radio station, let's enjoy the speaker effect provided by the device. The sound quality is excellent, especially the bass part, which is full and elastic.
生活在此刻，蓬勃在路上，映成更美好的自己，遇见更好的人。今天呢，我们的直播现场呢，依然是在我们的时光聚会啊，冰丝带的秋季。